In this video, we solve this differential equation given these initial conditions. So first, let's assume the solution is proportional to e lambda x, and we're going to solve the homogeneous differential equation. So we're just going to substitute y equals e to lambda x, and we have to take the second derivative and the first derivative. So the second derivative will be lambda squared times e to lambda x, and the first derivative is lambda e times e to the lambda x. From here we can factor out e lambda x and have lambda squared minus lambda minus 6 left over. Now e to lambda x is never equal to 0, so we can divide both sides by e to lambda x. And so now we need to solve, one is lambda squared minus lambda minus 6 equal to 0. So factoring that out, we have lambda minus 3 times lambda plus 2, and so lambda is 3 and negative 2. So now we can come up with a solution, which is y equals c1 times e to 3x plus c2 times e to the negative 2x. And so lambdas here are just the exponents of e. But now we want to find the particular solution by method of undetermined coefficients. So we have to let y sub p equal a times cosine 3x plus b times sine 3x, because in our original differential equation it's equal to 4 times cosine 3x. So you need to have both cosine and sine. Our goal is to solve for a and b. In order to do that, we have to first take the first derivative and second derivative and plug it back into the original differential equation. So the first derivative is negative 3a times sine 3x plus 3b times cosine 3x. And the second derivative is negative 9a cosine 3x minus 9b sine 3x. So now we just plug it into the differential equation and set it equal to 4 cosine 3x. Now we're going to distribute the negative here, and then the negative 6 gets distributed. So we end up with this. Okay, now I color coordinate the cosine 3x and the sine 3x. So for cosine 3x, we have negative 9a minus 6a, that's negative 15a, and then minus 3b. For sine 3x, we have negative 9b minus 6b, that's negative 15b, and then we have a 3a left over. And so that's going to equal 4 cosine 3x. At this point, there's no sine 3x here on the right, so we're going to set 3a minus 15b equal to 0, and then this thing is going to equal 4. So now we have a system of two equations, two unknowns. When you solve the system, you get a is equal to negative 10 over 39, and b is equal to negative 2 over 39. So now my particular solution is negative 10 over 39 times cosine 3x minus 2 over 39 times sine of 3x. And so I combine the solution when I found previously when I set the differential equation equal to 0. That's this part right here, and this is the particular solution. What's left for us to do is use the initial condition. So let's first take the derivative. So we have that ready. And so this is the derivative of y. So I have y and the derivative of y. Now I need to use these initial conditions. So first let's plug in y equals 1 and x equals 0. So for that, this becomes 1. This thing is 0. That's 1, and that's 1. So we have negative 10 over 39 plus c1 plus c2. That's equal to 1. And then when I plug in 0 for x here, I get 0 here. This is 1. That's 1, and this is 1. So that becomes negative 1 equals negative 6 over 39 plus 3c1 minus 2c2. So again, you get another system of equations, two unknowns. And so we solve that and get c1 is 12 over 13 and c2 is 1 over 13. So finally, we can combine this and say that y equals negative 10 over 39 times cosine 3x minus 2 over 39 times sine of 3x plus 12 over 13 times e to 3x plus 1 over 13 times e to the negative 2x. And that is my solution.